Today we're going to be dividing polynomial using long division and synthetic division. So let's go ahead and answer the first problem using long division. So I have 3x squared plus 4x minus 5. The first thing that you need to check is whether your polynomial is in standard form with no gaps in between. So if I have x squared, I have x to the first power and a constant. This is a complete set of my polynomial, so I don't need to worry about gaps in between them, and you will encounter that on the second example later on. So for the first problem, we are dividing 3x squared plus 4x minus 5 by x plus 1. So by long division, what we're going to be doing is we are dividing the first term by x. So you will ignore the constant right here, and we'll just focus on 3x squared all over x. And 3x squared divided by x is 3x. And we're going to write it out right here in line with this 4x with the same exponent. And just like long division, we're going to multiply it back to our divisor, which is x plus 1. So 3x times x is 3x squared, and 3x times 1 is 3x. And just like long division, after finding the or multiplying it out to the divisor, we're going to subtract our answer to the original polynomial. So we will change the sign since we're subtracting. So this becomes negative, and this will also become negative. And in the process, we'll be able to cancel out 3x squared, leaving us with 1x. And then we will bring down negative 5. And just like what we did on our first set, we're now going to divide 1x by x. So you have 1x divided by x is equal to 1. And you're going to write it out in line with the constant. So I have positive 1 over here, and then multiply it back to x plus 1. So 1 times x is x, or 1x. And 1 times 1 is 1. And by dividing it, we're going to change the sign. So minus and minus. So this is a common mistake that most students do, so please make sure to switch the sign when you're subtracting. So you have 1x minus 1x, and in the process it will turn to 0, so you know you're doing it correctly whenever you're canceling the first term every time you're subtracting your answer. So this is 0, and then you'll have negative 6, and since there's nothing else to bring down right here, we're finished with our answer, and the quotient of 3x squared plus 4x minus 5 will be 3x plus 1 with a remainder of negative 6. And another way of writing out our answer is we can write it out in standard form as 3x plus 1 minus, since this is negative, 6 all over the divisor, which is x plus 1. So we use the divisor as our quotient for our remainder. So this is how we use long division in dividing polynomial. Now, how are we going to use synthetic division in dividing the same set of polynomial on problem number 1? So the first set, or the first thing that we're going to be working on, is to write out our coefficient or polynomial. So let's say I have 3x squared plus 4x minus 5, and we are dividing it by x plus 1. In synthetic division, we're going to use the 0 of x plus 1, so we're going to solve for x in this particular factor. So this will turn into x plus 1 equals 0 minus 1. So we have x equals negative 1. And this is what we're going to be using as a divisor in our synthetic division. So we have negative 1 over here. And then we're going to write out all our coefficients. So I have 3, 4, and negative 5. 3, 4, and negative 5. So synthetic division is pretty easy and pretty quick. So the step would be to first bring down the first term, which is 3, and multiply it with our negative 1 over here. So 3 times negative 1 is negative 3, and then we add them up. 4 plus negative 3, or 4 minus 3, is 1, and 1 times negative 1 is negative 1. Adding this together, negative 5 plus negative 1 is negative 6. So to write out our final answer will be dependent on the highest exponent of our polynomial. Since we have an x squared in our polynomial, our answer or quotient will have a highest exponent of 1. So you always subtract 1 from the original polynomial in their exponent for our final answer. So if this is 1, this will be x raised to 0, and this will be our remainder. So to write out our polynomial in standard form, this can change into 3x plus 1 with a remainder of negative 6 all over x plus 1. So this is pretty much the same as the value that we got from dividing or using long division from the first set of example that we did. So long division and then synthetic division. Now for problem number 2, number 2 is a little bit different from number 1 because we have an exponent of 3, and when we checked our polynomial is missing a term, and that is the x squared. So before we can divide polynomial, it's best that we check our polynomial first for any gaps. And in this case, if I have x cubed plus 4x minus 5 to be divided by x minus 2, I know that I have a missing term right here, which is x squared. So our missing term, which is x squared, will be replaced by 0x squared. So we will write out x cubed and then the missing term, which is 0x squared plus 4x minus 5. So this will now be our new polynomial with a complete set of terms, and we're going to divide it using x minus 2 as our divisor, and we'll use long division for our first method. So let's divide it with x minus 2 and then x cubed 0x squared plus 4x minus 5. So just like what we did on the first example, we will divide x cubed by x, and we'll have x squared. We'll line it up with our square right here, and then multiply it back to x minus 2 minus 2x, and then we will change the sign. So this becomes negative, this becomes positive. So this cancels out, and 0x squared plus 2x squared is going to be 2x squared. And then we bring down positive 4x. And now we're dividing 2x squared by x, leaving us with 2x, and 2x will be written in line with our 4x. So to multiply it back, 2x times x is 2x squared, and 2x times negative 2 is negative 4x. And then we subtract. So we change the sign. This cancels out, and we'll have 8x. And then we bring down negative 5. So we'll focus on 8x again divided by x. So I have 8x divided by x, and this cancels out, leaving me with 8. So 8 will be in line with our constant. So we have positive 8, and then we multiply it back to x minus 2. 8 times x is 8x, and 8 times negative 2 is negative 16. And then we subtract it. Minus, plus, cancel, and we'll have positive 11. So this will be our remainder because there's nothing else to add or to bring down. So our quotient for the second problem will be x squared plus 2x plus 8 plus 11 over x minus 2. So this is long division, and to use synthetic division, just like what we did on the first step, we're going to replace x squared with 0x squared. So we have x cubed plus 4x minus 5. Since there's a missing term, we will replace it by 0x squared plus 4x minus 5. And then since we are dividing it by x minus 2 using synthetic division, we'll equate it to 0. So we'll end up with 2 as our divisor. So we will divide the coefficient of the polynomial, which is 1, 0, 4, and negative 5. And just like what we did, we're going to bring down the first term. 1 times 2 is 2. 0 plus 2 is 2. 2 times 2 is 4. 4 plus 4 is 8. 8 times 2 is 16. And negative 5 plus 16 is positive 11. And since the highest exponent in our original polynomial is cubed, our answer will have a highest exponent of 2, 1, 0, and the remainder. So our polynomial will be x squared plus 2x plus 8 plus 11 over x minus 2. Because x raised to 0, as we know, is equal to 1, and 8 times 1 is simply 8. So this is how we use synthetic division and long division in dividing polynomials of this form.